Hello everyone, my name is Mrutra Enoch and we're going to revise together Science Paper 1, that is Physics, for the grade 12s. The question reads, the diagram below shows the gear wheels. The driving wheel has 36 teeth and the driven wheel has 12 teeth. So that is just the figure showing the driving and driven wheel. So the first question they are saying, find the velocity ratio. So under this type of simple machine, what you should know is that the velocity ratio is calculated by dividing the driving wheel with the driven wheel. So we start. So from there, it's very important you indicate the formula. So velocity ratio is equals to driving wheel, you divide by driven wheel. So one thing that you should bear in mind is that sometimes you'll find to say they're not using driving wheel or driven wheel. Sometimes you'll find to say that they are using, where you are seeing driving wheel, there is input wheel, and then down there is the output wheel. So bear in mind to say velocity ratio is equals to the driving wheel. There in the question you have been given to say the number of teeth were, and then so the number of teeth or driven wheel that were there, you find to say that they are 36, and then for the driven wheel there are 12 there. So driving wheel, you're having 36 over what? 12. So velocity ratio is equals to, so when you divide 36 over 12, you're going to get 3. Now note that the velocity ratio that you have calculated, it has no what? A sign. So this is the final answer that was required to be at A. So we proceed to the next one. So the second the equation, they are saying if the driven wheel makes 15 rotation, how many rotation would the driving make? So also the second question is very simple, it's just the understanding. So what you are going to do is this. So what you are going to do is just the issue of doing ratio. So we are having driving wheel, which should be compared to what? Driven wheel is equals to what? So from there what you are going to do, this is driving wheel, which should be corresponding to what? To the number of rotation of what? Driving wheel. So number of rotation to the driving wheel is equals to what? Number of rotation to the driven wheel. So from there, the driving wheel, you're having what? 36. So it's 36 to what? To driven wheel, which is 12, is equals to the driving wheel is the one that you are calculating for, because in the question you have been given the rotation to be 15 for the driven wheel. So there I'm going to put X, and then there for the rotation of the driven wheel I'm going to put 15. So that is the same as writing 36 over 12 is equals to X over 15. So from there what you're going to do, since there is equal sign, you're going to cross multiply. So that is X times 12, which is 12X is equals to 36 times 15. And then divide both sides by what? By 12. Also this side by what? By 12. And then you cancel. So from there, if you simplify everything there, you're going to obtain. So you're going to obtain 45 rotation. So this is the final answer. It means that you have calculated, you have finished answering the first question. So bear in mind to say that I emphasize this, please take note. Sometimes you're not going to find where I'm putting driving wheel. You're going to find the other weight to be input wheel or driver's wheel, and then down there they can misplace it or use the other weight to be output teeth. So bear in mind. So please don't forget to subscribe, also share the video. See you in the next question, or we proceed to the next question. So the next question, they are saying the diagram below shows the part of micrometer screw gauge, an instrument used to measure a physical quantity. So one thing that you should bear in mind is that micrometer screw gauge has two renounced parts. So this part that you are seeing there is called the main scale, and then this part is what we call the thumb scale or the vernier scale. Now, obtaining the values from the main scale, or what we should do is that, or what we always do when the micrometer screw gauge has come in this form. So getting the readings, what you're going to do, you're going to start from 1, that is 1.5, and then you go there 2.5, from there 3.5, there you go to 4.5, meaning that is your reading in the main scale. And then when you come to the thumb scale or the vernier scale, what we do is that get the value which is coinciding or which is touching to the main scale, like this one there. So this is that one, and then that one is supposed to be, this is 30, and then that one is supposed to be 31. So that 31 should be multiplied with what? The accuracy number. So in this case, if you see clearly, the micrometer screw gauge, they haven't even provided any SI unit that you are supposed to use. So what you're going to do is that you're going to use 0.01, symbolizing millimeters always. But for the vernier caliper, if you have been not given, you also use 0.1 centimeter. We proceed. So they are saying the first question, what is the reading shown on the micrometer screw gauge? So we start. So to find the readings or total reading, so total reading, you write the formula total reading is equals to the main scale figure, you add it with what? Vernier scale figure. So from there, like I told you, we calculated our main scale figure to be 4.5, and this same figure should be added with the what? With the vernier scale. Now the value that was coinciding exactly, it was 31. Now this 31 that we obtained should be multiplied with the scale what? The accuracy number, which is 0.01 millimeters for the vernier calipers. Now what you should bear in mind is that sometimes you'll find to say that the micrometer screw gauge is in centimeter. So when it is in centimeter, the accuracy number that you are supposed to use is 0.001 centimeter. And then when it is in millimeters, millimeters, you are supposed to use 0.01 in millimeters always for the micrometer screw gauge. Note that. So from there, and then we simplify everything there, we find the final answer. So we are getting 4.81 millimeters. So this is our final reading. So we proceed to the second question. So the second question, they are saying, what physical quantity is measured by the instrument? So the instrument that is shown there is the micrometer screw gauge, and specifically the physical quantity which this instrument measures is length. So supposed to be length. So length, that is the physical quantity that the micrometer screw gauge measures. And then they are saying, what is the function of the ratchet? So that part that you are seeing there, called the ratchet, so it ensures the accurate and repeatable measurement. So see, function of the ratchet, it ensures accurate and repeatable measurements by applying consistent pressure to the micrometer screw gauge. So the role or the function of the ratchet is that it ensures accurate repeatable measurements by applying the consistent pressure to the micrometer screw gauge. So another one is that you can put it to say it ensures that the object that is being measured is gripped properly. Yeah, that one. It can also qualify to be your answer. So those are the possible solutions that we are supposed to be under micrometer screw gauge. So we proceed to the next one, to the next question. So the next question is under simple pendulum. So they are saying, the diagram below shows a simple pendulum that oscillates between position A and C. It takes 2.05 seconds to go from A to C and back to midpoint B. So the first question they are saying, calculate the the period of the pendulum. So we start. So what you should understand under simple pendulum is that a simple pendulum, that is just a small heavy bulb that is suspended to the inextensible light string. So when a bulb, this is called a bulb, and then this is called a string. Sometimes they call it a thread. And then what you should bear in mind is that when a bulb moves from point A to point B, the number of oscillation, that is 1/4, that is quarter. And then when it also moves from point B to C, that is also 1/4, which is quarter. Now, so that simply means that from A to to C, we are supposed to add quarter plus quarter, that is 1 over 4. 1 over 4 plus 1 over 4, you are going to obtain 1 over 2, which is half. So when a bulb moves from point A to C, the number of oscillation, that is 0.5, which is half. And then when it moves again from C to B, it also makes another what? Another quarter, which is 1 over 4. So if you add from A to C, which is half, plus that quarter, so if you add, so that is from A to C to what? To B. That simply means you're going to get that half, 1 over 2. You add it with the what? With this quarter there, 1 over 4. 1 over 4. So when you do your calculation, you're going to find that. So you're going to find that you're going to obtain a 3 over what? 4. So when an object moves from that point to that point, which is half, and then from that point to that point, which is 3/4. Now when it also moves from B to what? Back to A, it also makes another what? Quarter. So if you add this quarter plus 3/4, so A to what? To C, and back again. So A to C and back to A. That simply means that you are adding 3/4 plus what? 1 over 4. The common denominator there is 4. And then when you add the numerator, that is 4, which is 1 complete what? Oscillation. So whenever a bulb moves from that point to that point and back to its original position, that is, it makes 1 complete oscillation. So from there we can start answering. So first question, they said we calculate the period of the pendulum. So period of the pendulum is calculated by the time taken over number of oscillation. So like I said, so the time we have been given to be what? To be 2.05 seconds, and the number of oscillations. So an object moves from A to B to what? To C and back to B there. So meaning we are going to consider the second one, which is 3/4, to be our number of what? Oscillation. So that is 3 over 4 oscillation. So if you want, you can divide. So 3 divide 4, you are going to obtain 0.75 oscillation. So now just get those two values, you substitute in the formula. So period is equals to the time that you have been given, that is 2.05 seconds, over the number of oscillation, which is 0.75 oscillation. So period is equals to, when you divide, you're going to obtain 2.73 recurring. So the A sign for period is what? Seconds. So it means that you have calculated the final answer. So that is the value for period. So we proceed to the next one. So the next one, they are saying calculate the frequency of the pendulum. So what you should bear in mind is that frequency is calculated by this formula. Small letter f is equals to 1 over capital letter T, symbolizing what? Period. So frequency is equals to 1 over the period that you have calculated there, which is 2.73 seconds. So frequency is equals to, when you divide, that is 1 divide 2.73, you're going to obtain 0.37 Hz. So those are the SI units for what? Frequency. So we proceed to the next one. So they are saying B, briefly describe how the period of the pendulum would be measured. So the period of the pendulum can be measured by timing the large number of oscillation using stopwatch, and then dividing it by time given. So that is how we measure the what? The period of the pendulum. So by what? Measuring or by timing the large number of oscillation using a stopwatch, and then dividing it by what? By time given. Or the simplest thing is just to look at the formula. You find the what? The time given dividing by the what? The number of oscillation obtained by timing using what? The stopwatch. So we proceed to the next one. So the next one is under vernier calipers. So they are saying the figure below shows part of the vernier calipers used to measure a physical quantity. So the one that is illustrated there is called the vernier caliper, and you have been given the SI unit. So the rules are just very simple when calculating what? The reading of the vernier calipers. So they are saying what is the reading shown above the vernier caliper. So one thing that you should bear in mind is that the upper part that you are seeing there is called the main scale, and the scale below there is called the vernier scale. So the thing is that to find the total reading, you have to find first the what? The main scale. The main scale is the upper part. Now, how do you obtain the values for main scale? Is to get any value from the main scale without reaching or going or exceeding this zero that is below there. So what you're going to do is that, have you seen that number that is 4? So meaning this is 4 point what? 0.9, point what? 0.8, point what? 0.7. So this was so it means that what you're going to do there is to get the values. So starting from this side, going this side, but what you're going to do is that get the values not exceeding to this 0 that is below there. So that is 4. This is 4. It means that to reach at this 4, this part there was it was a 3.9, 3.8, 3 point what? 7. So it means that 3.7, that is the value that you are going to use as your main scale. And then down there, to get the vernier scale, get any value that is coinciding, or the value that is touching the main scale there. So if we see clearly, you find to say that this value there is coinciding with the top part. So that is 0, 1, 2, 3. So this is 3 that you have obtained there. It should be multiplied with the what? The accuracy number. Now bear in mind to say that the accuracy number that you are going to use is the one that is in centimeters. So we proceed, we start answering. So total reading is equals to many scale plus vernier scale. So what you're going to do there, we have found our main scale to be 3.7 plus the vernier scale. We obtained the value that was coinciding with the upper part to be 3, and it should be multiplied with the accuracy number, which is 0.01 centimeter. Now bear in mind to say that it's not always that you're going to find the vernier calipers in centimeters. Sometimes they can give you in what? In millimeters. So the rules are just very simple. When it is in the millimeters, the accuracy number that you are supposed to use for the vernier caliper is 0.1. When it is in millimeter, note that when it is in millimeter, the vernier caliper's accuracy number is 0.1. Now when it is in centimeter, the accuracy number is supposed to be 0.01. We have to bear in mind, note these two accuracy numbers. So from there, when you simplify, you are going to find your total reading to be, 3.73 centimeters. So that is your final answer. So we proceed. So they are saying, what physical quantity does the vernier caliper measure? So that is length. So that is the physical quantity, which is length. So we proceed to the next one. So they are saying, state 2 precaution that must be taken when taking measurement in the, I think they made a mistake, micrometer screw gauge. So the 2 precautions, the first one is supposed to be make sure the instrument is zeroed, or the second one, or the movable parts. So those are the 2 precautions that you should take into consideration. So please don't forget to subscribe, also like the video, so that whenever I upload the new video, you're able to get notified. So see you in the next lesson.